Welcome. Thank you for joining us. This is IITPSA's Blockchain Bitcoin Special Interest Group. Talking about smart contract will be John Singh, our board member and Special Interest Group Chairperson. But first of all, we're going to kick off with our little 3-minute video. So please sit back. If you haven't seen this before, hope you really get something from it. If you have, I think each time I see it, I pick something else up that's of use to me. So let me kick it off and we'll join you back in a couple of minutes.
As professionals in the world of information technology, we use our creativity, skills, and understanding of the world around us to make change. Each piece of code, technology, or information that we send out into the world takes on a life that has the potential to change the world around it. In our fast-paced world of AI, robotics, media, and communications, the actions we take dictate the future of these technologies. These technologies significantly impact people and the environment around us. As we grow, understand, and adopt AI both in our work and personal lives, we will be presented with moral and pragmatic decisions that can be used either in the upliftment or to the detriment of those around us. In everything we do, it is important to visualize, study, and calculate the impact that our creations will have. The fundamental way to achieve this is by imagining the impact your actions could have on you, your family, community, and society. Personal information can be readily stolen through phishing, viruses, and malware, leading to psychological, social, and financial harm to individuals. This abuse of personal information poses a threat not only to the affected individuals, but also to organizations at large. Imagine if this happened to you, your loved ones. We often underestimate the significance of our work, yet it's crucial to recognize that we are at the forefront of innovation. We play a pivotal role in propelling our world forward and shaping the future. We have the ability to mold our future into one that is filled with darkness, destruction, inequality, and unsustainability. It doesn't have to be this way, though. By using our skills, tools, and insights into the impacts our actions have on the world around us, we can build the future into something beautiful and exciting. A future that does not only benefit us, but benefits society and the generations that will come after us. We as information technology professionals can do this by always considering the ethical impacts of our actions. If you work in the ICT sector in South Africa, consider joining thousands of IT professionals committed to developing their unique skills across various sectors, all working towards building a stronger and more sustainable future for the greater good. To apply for membership with IITPSA, visit www.iitpsa.org.za.
Awesome. So there we go. And as I say, each time I look at it, it reminds me of something different. So thank you for joining us again. A quick shout out to our Gauteng chapter chair who's also online. Thanks for joining us. And to everybody who has come online since the video started playing, welcome. Once again, I would like to hand over to John Singh, who is a member of our board and also the chairperson of our special interest group in blockchain and Bitcoin. My apologies. John, thank you once again for the time you spent, and we look forward to and over to you.
Thank you very much, Tony, for the great introduction. And also I'd like to say that the ethics video was really excellent. I hope everyone enjoyed it. Thank you, everyone, and good afternoon for joining this blockchain special interest group presentation. The topic is smart contract, continuous integration, and continuous delivery reference architecture. In modern software development standards, CI and CD is quite well established, and the reason why it's so popular is because it automates many of the activities of the software development lifecycle. In practical terms, what it means is that as soon as the developer checks in his code to a repository, there's an automated process that will detect the code, build, test, deploy in a continuous lifecycle integration. It leads to better quality software and also removes many of the tedious tasks like testing that developers sometimes have to do and frees them up to do other tasks. When it comes to more modern technologies like smart contracts, CI/CD may not be as well established. So I've done this presentation just to introduce a reference architecture and possibly give some ideas on how to create one. In terms of content, we look at a basic development environment, then look at the CI/CD definition, then look at a comprehensive reference architecture, and also a small demonstration of some of the things I've done to try and implement this in Amazon Web Services. When it comes to smart contract development, it starts off with a developer using a IDE or integrated development environment to build some code. Most smart contracts on Ethereum are done using the Solidity language. So I've listed 3 IDEs. The one is Remix. So this is more of a cloud-based integrated development environment, very easy to use and very easy to start working with because there's no installation involved. Then there's Visual Studio Code, which is Microsoft's free offering, and IntelliJ IDEA from JetBrains, which is also a very easy to use software IDE. So once the code is developed, then you can use the Solidity compiler to compile the code. Then it's a matter of deploying to the blockchains. You can choose to deploy either to the mainnet. Now the mainnet is the live Ethereum blockchain. There is costs associated with this because in order to deploy your smart contract, you have to use gas. You have to pay gas fees, and that's the price to pay to actually use the Ethereum virtual machine. The testnet does not have such a cost. However, a developer would need to use a faucet to try and get ETH tokens and use that to pay for their gas fees. Obviously, it's not a real monetary cost, but nevertheless, you still have to get your tokens from the faucet. And then lastly, you could choose to deploy to a developer network, which is your local blockchain on your local machine. And that you can do as many times as you'd like because there is no actual monetary cost. All the tokens are literally dummy Ethereum because it's all local to your network, even though there is a process of creating them as you would normally do in the live Ethereum network. So a smart contract development involves writing code in a language like Solidity, compiling it, and deploying to a blockchain network. In a simple environment with a single developer just trying some code, it's easy enough to just install on a local machine and use a local blockchain network. However, when you have a large team working on a DApp or decentralized application, you have developers working on user interfaces, middle tiers, and also smart contracts. It becomes much more complex. So it's very challenging in the multi-developer environment, and this is where having better practices like CI and CD is more relevant and will help in many areas of solving quite complex problems that result from multi-developer involvement. In a simple environment, a developer could use Hard Hat Ethereum, which is a developer network which can be run locally. It's good for running tests debugging Solidity code without dealing with live environments. So it's all local to your machine and easy to install and run. It's a good choice for Solidity debugging, provides stack traces, console log, and error messages. It's also very flexible and customizable, and the local development environment works well for a single developer. So this is an example of an Amazon Web Service environment. There's 2 gigs of RAM, 1 CPU, 60 gigs solid-state drive, Ubuntu Linux, and I installed hard hat Ethereum, and I was able to easily create a smart contract, compile it, and run test cases on a local blockchain. So this kind of scenario, if you want to just try out Solidity development, try out a few smart contracts, very easy to set up, run, and do your tests without any monetary involvement and risk that will result from code that was not properly developed. So when it comes to CI/CD, CI stands for continuous integration and CD continuous delivery. So it is a process that automates software development and deploys better quality software. So CI and CD removes most manual intervention. So CI/CD pipeline automatically detects code changes and then builds, tests, and deploys. So the pipeline helps development, security, and operation teams work more efficiently together. So this is an example of a reference architecture. So this is courtesy of a solution architect at Amazon that constructed this reference architecture for smart contract development. You can see it's very heavily centered around Amazon type services, but nevertheless, it gives you an idea of how a CI/CD offering could be constructed for your development environment. We can see that there is a DevOps portion, and this consists of AWS code commit. Now, code commit is very similar to Git in that it is a repository. You can use a normal Git client to connect to it and then add and commit your code to that repository. There's also a AWS code build, which you can use to automatically compile, test, and build the code. And there's a pipeline which helps you automate the entire process. So to automatically detect the code, compile, and build, and then deploy to a storage system like the S3 bucket where all the deployable files are stored. In terms of the developer network, the reference architecture uses Hyperledger Besu, which is a open source project that's for Ethereum and it's good for both private and public blockchains. We use Elastic File System and also AWS Fargate as a serverless environment. At the top, you see there is a secrets manager. For the secrets, because smart contracts use public and private keys, the secret manager will store these and securely and safely. And then you have AWS Lambda for calling smart contract methods. We also have a Amazon managed blockchain service which can be constructed, and that allows you to easily and safely connect to both the test net or the main net, depending on what you're deploying to. And AWS Lambda is used for doing the function calls to the smart contract. So this very briefly is a discussion on the reference architecture. So it uses a lot of the Amazon web service type of components, and it is a little bit complex to set up because there's a lot of components involved, but once it is set up, it does run quite efficiently. So in terms of the components, I just wrote them down again. So Hyperledger Besu is a blockchain development network. Amazon ECS or Elastic Cloud Server is a managed orchestration service that simplifies deployment, management, and scaling of customized applications. Functions in the smart contract are invoked by code running in AWS Lambda. Amazon Elastic File System is used to store the blockchain database and all configuration files. AWS Code Commit is a version control service that allows you to store and manage the Git repository. And AWS Code Build is a fully managed build service that compiles code, run tests, and produces artifacts that are ready to deploy. So all these components working together will make up your CI/CD environment and will give you an automated and quality ensured process. Let's just look at a little bit more at AWS Code Commit as the repository. So in normal development processes, you have your developers developing applications. Then they would use either a Git client or the IDE to try and commit code to a repository. So in this case, the repository is on Amazon, and this is Amazon's Code Commit. So Code Commit is very much like a Git repository. It's encrypted, it has automatic scaling, and has high availability. So everything that you need in a secure and scalable repository. And developers can collaborate on code. They can use branching, merging, and use all the features of Git that enables a smooth development process when there's multiple developers. And then you can automate your pipeline using code build, code pipeline, and other CI/CD systems. So it's an all-encompassing solution, and it can all be found on the Amazon Web Services side. In terms of the steps in the pipeline, your developer would create the code using an IDE and then commit this to the repository. So in this case, AWS Code Commit. And the code pipeline, which is the automated service, would trigger the code build to compile the smart contract. Code build will deploy the smart contract to Hyperledger Besu, which is the developer network. The code build will run the test scripts automatically. The code build will update the Lambda function with the latest smart contract application binary interface and the deployed smart contract address. So remember, in smart contracts, when you deploy them, you do have to have a public key associated with it and the associated private key. And the application binary interface is like the core interface to that smart contract, but all in binary. A manual approval is needed to move the code to the next stage, and code build will deploy the smart contract to the GUI test network. On smart contracts, it's like in all software development, you need to have some form of structured process that helps you deliver quality software that meets basic business requirements. So the business requirements could be anything. It could your smart contract could be used for all kinds of financial instruments, and you need to be able to be clear on what those requirements are. So when it comes to continuous planning, you need to discover all the details of your requirements and make sure that they agree upon with the business-facing people. Then once you have those, then you can plan your task and issue tracker, and then start assigning resources to these tasks. So once the tasks are assigned to a developer, then your developer can start doing their process, which is to code the assigned task and then create unit tests for their developments and commit the code into the repository. So once the code is committed, then the automated build process and pipeline will then compile the code, run the tests, and continuously do this. So when it comes to the testing part, it consists of both static and dynamic analysis of the code. So they both help because they check the code for quality. They also check for security flaws, and they do other testing, business type functional testing as well. And then once it's tested, the build can be released into the private blockchain, and you run more unit tests on the developed code, and you run integration tests between the different units of the program. So sometimes if this specific development's not completed, you can use mock services to try and replicate that service, but it's very important to do integration testing as well once all services have been completed or components of the solution have been completed. And then it comes to continuous deployment. You generate your release and deploy the release into the blockchain. It can be the live blockchain or the testnet, depending on your preference. Yeah. Then once it's out there live, and there's continuous monitoring of the smart contract, the client, and monitoring permissions and generating feedback. So all this leads to a more quality solution that can be, you ensure that you put out more quality code that is secure, less risk of a monetary kind of infringement that will occur during the lifetime of this project or solution, and you get continuous feedback on it. Now, in terms of what I specifically did, I did try to construct an AWS cloud environment, and I created a AWS server with 2 gigs of RAM, 1 CPU, 60 gigabytes solid state drive, and Ubuntu Linux. And I was able to construct a repository in code commit and actually commit changes, a smart contract change to that repository. I was able to create a code build project and call various commands that would compile using hard hat Ethereum. And then I used identity and access management portion of AWS to have a user that had the correct rights to interact with the repository and also to do the code build steps. And then there's also S3 storage to store various deployed artifacts. So I'm going to switch to my Amazon AWS instance just to show you what I've done. So this is the tricky part of the presentation because you never know what's going to happen when you do something live, but I will do my best to show you what was done in Amazon itself. So just give me a moment. Okay, hopefully this is quite visible. So if you see my mouse click, I'm now clicking on identity and access management in AWS. So this is where you set up your users. And I'll set up a user for myself. And this user has various rights associated with it. So you can see the one is to administrator access. There's also one for doing code commits and running code builder, etc. But this is the place where you set up your users and your various roles. You can see there's a code deploy service role. There's a code build Solidity build service role, which I have created, and that all helps for this user to be able to carry out the functionality in the pipeline. So setting up identity access management is not difficult, but I think the learning curve is a bit steep because you have to read a lot of documentation just to understand how to do it. But nevertheless, once you know how to do it, it's not too hard to do. It's just a matter of being able to read quite a bit of documentation first. And then if I go back a bit, I'm going to go to my code build instance. We'll just look quickly at the source repository. So I call this repository smart contracts, and so I have this .sol file in it which I committed. So this is example of a smart contract. So it's not a very difficult smart contract. It just keeps a list of addresses to pay to, and then it allows transferring of money to various people in that list. So it's not a very sophisticated one. It's just a simple one, just to try out and to compile and to deploy it. So the other interesting thing is the build spec. So this is used by code builder to decide how to compile, build, and deploy. So I have some commands to install hardhat, initialize the environment, and then change directory to the correct source directory, and then try and compile. So interestingly enough, if I go to my build repository, I will very honestly share with you that it didn't work very well. You can see that it's got a big red status of failed on it. And the reason is because it's unable to initialize the hardhat environment in this type of shell. So I clearly need to use a more simpler way of compiling my various smart contract components. But nevertheless, it's a learning experience for me. I wanted to show you honestly what I did. Even though I found the fancy reference architecture, I wasn't able to complete implementing it, but it's more about me not really understanding AWS that well. But this is as far as I got, but I will continue trying to work out how to automate the code build, etc., and maybe feedback at some other time on the success of it. So that was just start the presentation again. Okay, so I'm back on the presentation. So that's the environment I set up. And lastly, just to, as I said, I did use the reference architecture shown by the AWS blockchain solution architect, Rafia Tapia, and used all the guidance from there to show you this reference architecture. So it is very comprehensive, but as seen, with the amount of AWS components, it does become complicated to set up, but nevertheless, I think it is achievable with a little bit of work. So hopefully I gave some ideas as to how to construct a CI/CD environment, and hopefully you all learned something. So thank you very much for your attention, and I think we'll be open to any questions that people have. Yeah. See if there are any at this stage.
Thanks, John. I'm not seeing any questions yet. Let's give the guys a moment to digest all of that. So, for the totally uninitiated, that's me. What you say you experienced, so what, maybe like just real basics, what exactly is a smart contract? What does it do?
Okay, in blockchain terminology, it's a piece of code that runs on the blockchain, but the special thing about it is that it's decentralized, so it runs on literally thousands of computers across the world because it's a decentralized system. So that makes it very special because it makes it like a world computer. So this smart contract or piece of code can run But in practical terms, people use it for creating tokens. So you may have heard of something like non-fungible tokens that are used for art and for the
I attended your talk on that, John. I remember it.
yeah. So in practical terms, you use it for things like that, for building various types of tokens that you want to use. So I think you can associate monetary value to it. So if you look at decentralized finance networks, they're using smart contracts to try and control their tokens and produce value out of them. Yeah? And it actually allows you to self-govern your decentralized finance environment as well, because the code will set out all the rules that are required in your environment and makes it a totally self-governing environment. So smart contracts can be used in that way as well, to make a fully decentralized, self-governing financial environment. Yeah. It has been done to an extent. There are some decentralized finance solutions that are making a good job of it, but it is difficult. It's not an easy thing to do. Yeah.
Okay, still don't see any questions as yet. Just maybe one other from me, John. I mean, I personally happen to know what you do for a living in terms of your job, but maybe not everybody else does. And I'm just wondering, so do you do, blockchain and Bitcoin as a hobby, or is it just something you're interested in and want to get into at some point?
Yeah, at the moment, it's purely a hobby. So, the thing with blockchain and smart contracts is that it does have financial implications. And while it has become a little bit more mainstream, it still is viewed a little bit skeptically in terms of regulation, etc. So it's not easy to introduce something like this to an organization, because you don't want to flout regulations, especially if you're dealing with a lot of customers, etc. So I wouldn't use it in my day-to-day job, but it's a hobby and something that I'm interested in and hoping to contribute to developing the ecosystem where one day it will be accepted as just normal run-of-the-mill. We don't have to worry about whether you're going to be cheated out of your hard-earned funds or there's going to be a tax or that kind of thing. So still early days, but I think there's been a lot of positive developments, a lot of new mainstream funds that are now acquiring Bitcoin into their portfolios. So I think that's gaining a lot of traction, and soon it will be, very much a case of, it's just one of the asset classes that you can use or a currency that you can use, but we're not there yet.
Great, thank you, John. I see there is a question from one of our loyal and long-standing members. Hi there, Mishak. He asks, is a smart contract permanent? And he's saying once written and deployed.
Yeah, anything written is immutable and unchangeable. Yeah.
Great, thank you, John. I really don't see any other questions. So if we don't get any in a short space of time, I guess we can probably end off there. Was there anything else you wanted to close off with, John, in terms of smart contracts and maybe other suggestions? I mean, you said you struggled with was it AWS implementation where you had the lovely fail crossing? Thank you for being honest and sharing. That's great. Any sort of insights or suggestions for others who are experimenting in this way?
Yeah, I would say so. I mean, when I started out thinking about this presentation, I obviously had a great big idea and a vision, but practically it didn't work out. But nevertheless, I think these kind of attempts are important because you get to get some learnings out of it, and then you start to understand what it is that it takes to build a development environment that would be quality driven. So I think it was a good learning for me, and hopefully people in this audience have learned a little bit as well. So I'm not saying it was a perfect implementation, that I was able to show you a perfect implementation of the reference architecture. But again, for me and how I do this is that I research and I do things, and I feed back to the community whether it works or doesn't work. I feedback whatever I do, and it may not be perfect, shiny, and all sparkles, but at least you get the honest assessment of how to do it. And I'm just like a normal, like everyone else, trying to learn the stuff. So hopefully you all learn with me as well. Yeah.
That's awesome, John. And I think we all know life is never perfect, shiny, and what else did you call it? Well, certainly not all it. Well, certainly not all the time. John, thank you for sharing. It was very interesting.